What I was saying, dear students, is that today we are going to discuss logarithmic inequalities. And before I start class, could you please confirm that you are able to hear my voice clearly and view the screen properly?
Yes.
Okay, great. So, dear students, in logarithmic inequalities, what we are going to discuss? We are going to discuss, if we have a inequation, something like that, log of f1x base gx, suppose, is greater than equal to log of f2x base gx. Now the point is that if this kind of inequation is there, then what will be our target, to find the solution to these values of x? Find the solution to this inequation is to find the set of values of x satisfying this inequation. And for that, what you need to do, dear students, is that it is convenient that if we can convert this linear inequality to an inequation related to f1x and f2x. Correct, no? So what I wanted to mean by that, if I can, exactly represent that when you say that log of f1x base gx is greater than equal to log of f2x base gx, then what we can see is that if we can make this relationship in terms of f1x and f2x in inequation, then it is very easy to solve, because f1x and f2x, mostly it is an algebraic equation, algebraic function, sorry. Mostly it is algebraic function. So it is f1x, greater than equal to f2x. I'm just giving an example. We'll discuss in details. Before that, I'm just, giving a justification why, we should convert these logarithmic inequalities to the inequalities related to the function f1x and f2x. 90% of the cases, dear students, these f1x and f2x, you will find algebraic functions. 10% you will find the other functions like trigonometric functions, inverse trigonometric functions, exponential functions, very rare like that. But mostly we can confine that it is, algebraic function. So it can be, so log of f1x base gx greater than equal to log of f2x base gx can lead to a discussion that f1x is greater than equal to f2x, or we can say f1x less than equal to f2x. That is also possible. f1x less than equal to f2x. And who decides which branch It is defined by the function gx. So for example, if gx is greater than 1, we can say that f1x is greater than equal to f2x. And if gx is less than 1, what we can say is that f1x is less than equal to f2x. So what we find, dear students, is that depending on the base, that is gx, the logarithmic inequality is actually converted to the inequation in terms of f1x and f2x. Now, it is easy to solve. In fact, I can say it is easier to solve f1x greater than equal to f2x or f1x less than equal to f2x rather than solving log of f1x base gx is greater than equal to log of f2x base gx. So this is the justification that why we should convert the logarithmic inequalities to the inequalities related to the function f1 and f2 in context to the discussion what we are having. And the moment you find f1x is greater than equal to f2x and f1x less than equal to f2x, it will be very easy to solve. Let me give an example so that you can completely understand why I'm saying so. For example, a question is given to you something like this: solve the inequality. We'll do it later the class. Okay, you know, we will do this particular question, but I'm just informing you here. Suppose a question is given to you something like this: solve the inequality log of 4 by x plus 3 base 2 is greater than log of 2 minus x base 2. The moment you get this inequality, dear students, is that it is very easy to convert it to the what is f1x in context to this discussion what we are having. F1x is this 4 by x plus 3, correct, no, dear students? And what is f2x? 2 minus x. So if we can convert it to f1x greater than f2x, it is easier, no? What is the base 2? What is the base here? Base here is 2. 2 is always greater than 1. So we should take this branch. Let me use a different color. Okay. We should always take this branch because base is always greater than 1 here. So what we get, 4 by x plus 3 is greater than 2 minus x. Now, solution to this inequation is pretty simple. You can do it. You can do it using wavy curve method, what we learned. This is the first one. And second one is that, if you recall, dear students, when we had a discussion on logarithmic functions, we understood that logarithmic function is valid if that value is actually logarithm of a negative number doesn't make sense. It is not defined. So what we can get? 4 by x plus 3 is greater than 0, na, dear students? Are you getting my point? All of you agree to me? And 2 minus x, that is also greater than 0. If any one of you disagree to me, never hesitate to let me know. Clear, no? So, because logarithmic of a negative number is not defined, now solution to this inequation, consisting of log, is equivalent to solution to this inequation as you see in this, what I wrote in the green 3 inequations. Pretty simple. And whatever the solution we are going to get it from here is the solution to the given inequality. So this is the justification that why from the logarithmic inequation we should convert it to the inequation related to the mostly for the algebraic functions. Correct, my dear students? So now how to perform that one? So we need to understand the methodology. Dear students, the way I teach, I always go with the step-by-step methodologies. As we have a fair amount of idea about the logarithm function, then we are going to discuss first that few logarithmic inequalities and their corresponding corresponding form. For example, first I'm going to discuss with the elementary logarithmic inequalities. Let me first bring this point and then let's discuss. Dear students, please confirm that all of you are able to view it properly. Means this is clear view, na?
Yes.
Yeah. So what it says that if first point, if you see, dear students, is that if a is greater than 1, a means the base of the logarithm. Okay. If a is greater than 1, then the inequality, that is 0 less than x1 less than x2 and log of x1 base a less than log of x2 base a are equivalent. That means one follows the other. That means what? For the first few steps, first few points, let me explain in details. When the base of the logarithm is greater than 1, 0 less than x1 less than x2, actually 0 less than x1 less than x2, we can convert it to x1 less than x2 because log of a negative number is not defined. We are all understood by this time. So x1 less than x2 is implying that log of x1 base a is less than log of x2 base a and vice versa. And that's what we have done in this particular question. If you look into it, dear students, what is the base here? Base is 2, na? Which is greater than 1. So obviously, then 4 by x plus 3 is greater than 2 minus x. We conclude this decision. Similarly, if the base, so base plays a very very integral role to change the inequation. See it here. When gx is greater than 1, it is one thing. When gx is less than 1, it is different thing. So always give a full focus on the base as long as the logarithmic inequations are concerned. Second point, dear students, if the base is in between 0 to 1, means 0 less than a less than 1, then the inequality 0 less than x1 less than x2 is implying that log of x1 base a is greater than log of x2 base a. These two are equivalent. Equivalent means what? One actually follows the other and vice versa. And that also you understood. Now the third point is that if x a is greater than 1, then log x base a less than k and 0 less than x less than a power k are equivalent. Now the next one is that if a is greater than 1, then the inequality is log of x base a greater than k and x greater than a power k are equivalent. And the last 2 points, 0 less than a less than 1, then the inequality log of x base a less than k and x greater than a power k are equivalent. And 0 less than a less than 1, log of x base a greater than k and 0 less than x less than a power k are equivalent. These are, elementary logarithmic inequalities. But what we are going to learn now, we are going to learn little advanced. For example, what is meant by little advanced? If you see here, we discussed about the where a is greater than 1. What is a? A is in a number. It is not a function. Correct, no? But you see here what we discussed, log of x1 base gx, where the base is not a constant number. Base is also a function. So when base is a function, then how to proceed? You should also be knowing this, that when base is a function, so all the cases, I covered and make it a very structural manner. Means very, you will find it actually that if you remember that table, it is actually going to be very clear. And that we are going to discuss. Before that, what I'm going to say, dear students, the two fundamental points. Two fundamental points are what? An inequality of the form log of fx base a greater than b. A inequality of the form log of fx, let me first place it here, dear students. Yes, as you see here, dear students, is that at inequality of the form log of fx base a greater than b is equivalent to the following system of inequalities. The first one is that fx greater than 0 and fx is greater than a power b for a greater than 1, and fx greater than 0, fx is less than a power b for a in between 0 and 1. By the way, fx greater than 0 is so obvious. It is otherwise the log function is not defined. So you can omit that also, because if something is quite obvious, is very, very true, without that holding true the other things, you cannot proceed. So you can assume that. But as it is an abstract function fx, so we mentioned it here is that fx has to be greater than 0. Correct, my dear students? Now, the next point what I'm going to discuss is that an inequation of the form. Now, we discussed about the log of fx base a greater than b. Then what is going to happen if the log of fx base a is less than b? That case also we should cover. And here it is, dear students, is that An inequality of the form log of fx base a less than b is equivalent to the following system of inequalities. The first one, fx greater than 0, fx less than a power b if a is greater than 1. And second one is that fx greater than 0, fx greater than a power b if a is in between 0 and 1. If you look into these two cases, dear students, very minutely, you will find the one is the, complement of the other. Correct, no? One inequality which is hold true for a condition exactly opposite, it is holding true for the other inequality. And in case of, by and large, all the, logarithmic inequalities are like that. If you change the inequality, then you change the base and you will get, you change the inequality for the base, you will get the same thing. For example, what we see here, log of fx base a to the base b, na, greater than log of fx base a greater than b. For that, what is that solution? Fx greater than a power b when a greater than 1. And that is exactly true when log of fx base a is less than b, and fx greater than a power b is going to be true here when a is 0 less than a less than 1, which is exactly the opposite case of a greater than 1 of the previous inequality. I hope all of you got my point, now, dear students, what I wanted to mean. Means if you remember one, then it is helpful to, recall the other. Let me give you an analogy. For any value of theta, sine square theta plus cos square theta equal to 1. For any theta, na? So now if you only know the values of sine, angle of different, suppose 0, 15, 30, 45, 60, 90, if you know the value of sine in all these angles, then you can find the value of cos because you know the relationship. Cos square theta is equal to 1 minus sine square theta. In the same context is, in analogy is same. In the same analogy, what we can say is that if you remember the solutions, what are the inequalities are going to be hold true for log of fx base a greater than b, then you just change the inequality of the base, you will get the same solution for the solution of log of fx base a is less than b. This I just discussed to help you to understand that how by remembering one solution you can find the other. And we will see in several other cases also. Now what I'm going to discuss, dear students, is the most important part, and that covers everything. Original and corresponding equivalent form of logarithmic inequalities. So this table, you need to remember what the table I'm going to discuss now. This is an important table, dear students, and if you remember this table, then any problem related to logarithmic inequality will be very helpful to, will be very easy to solve. Will be very, very easy to solve. And we'll see it today by solving a few inequalities. But before that, I would like to explain you that each and every entry of this table. You can take a printout of this table. Once you get the class note, put it in your, study table. So that you can always follow this thing. Okay, I hope all of you are able to view it, dear students. Just confirm once that you are able to view it.
Yes, sir.
Okay. Yes. Great. Thank you very much. Okay. So what you see here, following are the some important logarithmic inequalities. Okay. And their corresponding equivalent form depending on the value of the value range of the base of the logarithm. Base played a very important role here. You remember, dear students, before we start that class, at the beginning of the class, whatever the example I gave, na, log of f1x base gx is greater than equal to log of f2 base gx. So this is one entry of this table. this is one entry of this table. Actually, this is the last but one entry if you look into it. Okay, so now this shows that why it is very important to remember this table. If you remember this table, it will take some time. You are not going to appear the entrance exam tomorrow, right? You are going to appear after 1 year, 10 months or so. So you have sufficient time, but you should take 1 week to remember this thing. That is my humble suggestion. Now let us discuss each and every entry of this table. And here also you can use the concept what I said few minutes back, that just by if you see the inequation get changed of the logarithmic inequation get changed, then the solution set remains same if you change the inequation set for the base. Let's take the first example, first entry, not example, first entry. If you see the first entry, that log of fx base a greater than equal to 0, then fx is greater than equal to 1 when a is greater than 1. This is the equivalent form. And 0 less than fx less than equal to 1 when 0 less than a less than 1. That is the first entry. Second entry is that, dear students, is that log of fx base a is less than equal to 0. So this solution set is equivalent form 0 less than fx less than equal to 1 when a greater than 1. And fx greater than equal to 1 when a is in between 0 and 1. If you look into it very minutely, the inequations, that is the equivalent inequations, is actually same when you change the equation for the base. Correct, no? Fx greater than equal to 1 is true for what? A greater than 1. And the same thing is going to be true when a is in between 0 and 1, in case the inequality gets changed. Correct or not? So if you remember one, you can remember the other. I hope you agree to me, dear students. Now, if you say, no, sir, I do not want to make that analogy. I want to, remember each and every entry the way it is. Fine, go ahead, no problem. But if you want to make your memorization, little optimized way, you can follow the guidelines, what I just said. Now, let's come to the next point. Next point is that log of fx base a is greater than equal to b. If you see, dear students, log of fx base a greater than equal to b, it says that fx is greater than equal to a power p when a is greater than 1. And fx is in between 0 and 1, not including 0, but it can include 1. That means 0 less than fx less than equal to 1 when a is in between 0 and 1. That is 0 less than a less than 1. The same solution set varies is that when you go for log of fx base a is less than equal to b. Log of fx base a less than equal to b says that 0 less than fx less than equal to a power b when a is greater than 1, and fx is greater than equal to a power b when a is in between 0 and 1. Correct, dear students? You got my point? Clear?
Yes.
Okay. So this is one solution set. So now, next one is that log of fx, log of fx. So there is a mistake I have made it here by writing it should be a power b. It should be a power b. So just by remembering one, you can remember the other. Correct, dear students? Now let's look into the next case, that log of fx base gx is greater than equal to 0. We can conclude that if gx is greater than 1, then fx has to be greater than equal to 1. And if gx is in between 0 and 1, then fx has to be in between 0 and 1, excluding 0 but including 1. This is the one. Second one is that log of fx base gx is less than equal to 0, implying that fx is greater than equal to 1 when gx is in between 0 and 1. And fx is in between 0 and 1, including 1 but excluding 0 if gx is greater than 1. And if you look into these two cases, dear students, if you remember one, you can remember the other using the same methodology I explained earlier. Correct, no? Now the next case what we are getting, dear students, is that log of fx base gx, and we are now shifting our discussion to the more generic, where the base is actually gx and function is fx, and earlier we discussed about greater than equal to 0, now we are greater than b. So what we are saying, dear students, is that log of fx base gx is greater than b is implying if gx is greater than 1, then fx should be greater than gx to the power b. And if gx is in between 0 and 1, fx should be less than gx power b. Correct, no, dear students? The next one, what we are going to discuss, dear students, is that, when you get that log of f1x base gx is greater than equal to log of f2x base gx. When log of f1x base gx is greater than equal to log of f2x base gx, this implies f1x greater than equal to f2x when gx is greater than 1, and f1x less than equal to f2x when gx is in between 0 and 1. This is the point we have discussed now. The next one is that, which is related to the previous one, only the inequation gets changed. That is, log of f1x base gx less than equal to log of f2x base gx is implying f1x less than equal to f2x is gx is greater than 1, and f1x greater than equal to f2x if gx is in between 0 and 1. So as you see, dear students, that these two inequations are solution, equivalent form of these two inequations. You can derive, if you know the one, you can derive the other. Now the next one is that, dear students, is that log of f1x base a is less than equal to log of f2x base a, implying f1x greater than equal to f2x if a is greater than 1, and f1x less than equal to f2x if a is in between 0 and 1. Correct, no, dear students? So what I suggest you now, go through this table once, or you can take a take a snapshot of this thing or screenshot of this particular screen, okay, so that whatever the problem we are going to solve now, you will see just by remembering this table, it is going to be so easy to solve. And always remember that log of fx with respect to whatever the base is only defined if fx is greater than 0. Or the other way I can say, log of a negative number is not possible. You can visualize the curve, what we discussed earlier in the class of logarithmic functions, that if you always see that the log of that curve of the function y equal to log x base a is always in the right side of the y-axis. Correct, my dear students? If I just, this is also very relevant so that you remember this thing. So this is the x-axis. This is, x dash, negative direction of x-axis. This is positive direction of y-axis. This is negative direction of y-axis. This is origin. Let me draw the curve in a different color So it log is something like this. That is equal to y equal to log x. In a very, there are several other corner cases with respect to the base is, whether the base is in between 0 and 1 or not, whether the base is greater than 1 or not. So all these things you can look into my earlier class video lectures available. But what I wanted to say is that whatever the value you find is that you'll always see that the curve is not defined when you go to the negative of the x-axis, that is the left of y. Correct, no? You will never find a value of x which is in this region of the negative one of negative of x-axis. If I use a different color, if you will not able to find for any value of x in this region, what I drawn in the green color is a function is actually defined. So in simple terms, what we can say is that log of fx base a is defined if fx is greater than 0. This is a very important piece of information. Why? Because whenever you will solve the linear inequalities related to the logarithm, okay, you will always find that fx greater than 0, whatever there for which you are finding the log should be greater than 0. Let me give you an example. We discussed today. You look into this one, log of 4 to the base 4 by x plus 3 to the base 2. If you look into this one, is greater than log of 2 minus x base 2. What you have done? If you look into the second and third point, we actually found that whatever the log 4 by x plus 3, that is actually going to define if 4 by x plus 3 is greater than 0. Suppose for some reason you say, no sir, 4 by x plus 3 is less than 0 and you need to find the solution. Simple answer is that not possible. You are giving me a range by saying 4 by x plus 3 less than 0. With this range, you are defining me x such that my log is not defined at all. The function is not defined at all. Forget about finding the solution. If the function is not at all defined, how I can find the solution? So these are the fundamentals. So what I said is that also you should always remember. So now let us, I hope all of you take a snapshot of this screen, and we will now start solving the problems. Now let's first start solving the problem. What the first one. Okay, you are going to get this question in a few seconds. Okay. So the question here is that find the value of x. Find the value of x for which log of 3x plus 1 base 2 minus x is positive. Now, dear students, let's deep dive into that log. If that log has to be positive, then what has to be done? It depends on the base. If the base is greater than 1, then that log also has to be greater than 1, that log for that value function 3x plus 1. So what I wanted to say is that this one is actually derived by the value of 2 minus x. So what I say is that if 2 minus x is greater than 1, let me write properly. If 2 minus x is greater than 1, it is something. And if 2 minus x is in between 0 and 1, it is something different. If 2 minus x is greater than 1, we can say that yeah, 3x plus 1 is greater than 1. And if 0 less than 2x less than 1, you can also say that 0 less than 3x plus 1 is less than 1. You can look into the table and you agree to this one. So then what we are going to get? So we are going to get 2 minus x greater than 1 and 3x greater than 1. So if you look into these two, 2x minus 1 greater than 1 and 3x greater than 1. So what we are going to achieve? Let's see what we are going to achieve. We are going to achieve something like this, that 2x 2 minus x greater than 1, that means x is less than 1. And 3x plus 1 greater than 1 means what? 3x greater than 0, that means x greater than 0. So from here we are going to get x greater than 0 and x is less than 1. So that means what? From here we are going to get 0 less than x less than 1. Correct, my dear students? I hope all of you agree to me. Now let us focus into the other part. Okay, what is the other part? Other part is that 0 less than 2 minus x less than 1 and 0 less than 3x plus 1 less than 1. Let's see what we are going to achieve from here. So from here what we are going to see is that 0 less than 2 minus x less than 1, it actually says that 1 less than x less than 2. Correct or not? It says that 1 less than x less than 2. You can simplify. And 3x plus 1 is less than 1 means is that 3x is less than 0. And also not only that, we can say minus 1 by 3 less than x less than 0. And minus 1 by 3 less than x less than 0. Now if we club together, so what we are going to get? 1 less than x less than 2 and minus 1 by 3 less than x less than 0. Correct? So now if you look into it, that 1 less than x less than 2 and minus 1 by 3 less than x less than 0, okay, what we can get? We get nothing. This doesn't have any solution set, right? Can you get some value of x which satisfied by both 1 less than x less than 2 and minus 1 by 3 less than x less than 0? Not possible. Here the word and is a very meaningful word, dear students. I have explained earlier also. And is very important. If it is or, then it is completely different. Yes, solution exists. As the word is and, it is not. And is actually correlate to the set theoretic notation intersection or correlate to the set theoretic notation union. I already sent you the my video lectures for for sets. You can get it from my YouTube channel also. So you will have a very clear idea that very huge significance about this word like and, or, but. Okay, all these words has very proper significance in the set theoretic notation. So finally what we are going to get? We are only going to get is that 0 less than x less than 1 is the solution set. All of you agree to me, dear students? Okay, now let us focus on to the some other questions we are going to solve together. Okay, and this is the question what I gave at the beginning of the class, and we are going to solve it now together. Okay. So here the question is that solve the inequality log of 4 by x plus 3 base 2 is greater than log of 2 minus x base 2. If you follow the table, okay, then what you can conclude? We are able to conclude three things. The first one we are going to conclude is that definitely 4 by x plus 3 has to be greater than 0. Correct, na, dear students? Otherwise the log function will not get defined. Second one, what we can conclude is 2 minus x, that also has to be greater than 0. And third one, from the table what I discussed today, we are able to confirm that 4 by x plus 3 should be greater than 2 minus x. 4 by x plus 3 is greater than 2 minus x. Now what the task we have in our hand is to solve these three inequalities. 4 by x plus 3 greater than 0 tells what? It tells that x is greater than minus 3. Correct or not? Obviously, because 4 is positive, So x plus 3 has to be positive, no? So from here, what we can get is that x is greater than minus 3. Now 2 minus x less than 0, greater than 0, it says that x is less than 2. So we can stop these two. So what we are going to get from there is that minus 3 less than x less than 2. So this is one solution set we get. But that is not the only one. Along with that, we need to consider the third one. So third one, if we concentrate, dear students, if you recall my earlier guidelines, that we should bring 2 minus x the other side. So 4 by x plus 3 minus 2 minus x is greater than 0. Correct, not, dear students? So from here, what we can do, we can make the simplification. So x plus 3 is the LCM. Okay. Then what we are going to get, 4 minus 2x. Okay. 4 minus, so 4 minus 2 minus 6 into x plus 3 greater than 0. This implies, we can simplify the numerator. We are going to get x square plus x minus 2 if you simplify, dear students. X square plus x minus 2 divided by x plus 3 is greater than 0. Now, x plus square plus x minus 2 implies what? It implies that x plus 2 into x minus 1, x plus 2 into x minus 1 divided by x plus 3 is greater than 0. Correct or not? Now you know Wavy-Curve method, and we can use that Wavy-Curve method to find the solution. So how to find the solution using Wavy-Curve method? It is greater than 0. So first we will write x minus of something, no? X minus of minus 2, then x minus 1, and then x minus of minus 3. Okay, that is greater than 0. So now let us draw a number line. Let me draw a number line in different color. Suppose in the green color, I draw the number line. So midpoint is 0. Right hand side it goes up to infinite. Left hand side it goes up to minus infinite. And I will keep this point minus 3, minus 2, and 1 relatively. So this is minus 3. This is minus 1. Sorry, minus 2. Minus 3, minus 2. Minus 2. And this is 1. Relative position. You don't need to be, as I always say, you don't need to be precisely correct with respect to the distance, but they have to be precisely correct with respect to the relative position. So minus 2 should be always right of minus 3. It should not be the other way. 1 should be always right of minus 2 and right of minus 3 as well. That relative position has to be absolutely correct. Otherwise, your solution is going to be wrong. So now for what the numerator, these points we will make it as a filled up circle for minus 2 and 1, dear students. And for the denominator minus 3, I will make it as an unfilled circle. After that, what I'll do, dear students, I'll get a point which is more than 1, and I'll keep my the tip of my pen on the above the number line here. Then I start drawing. I come down x minus 1, x minus 1 power 1, which is odd. I cross the number line, come down, go up. X minus 2, x minus 2 power, x minus minus 2, that is x plus 2 power is 1, which is odd. So again I will cross the number line, go up and come down. What is that? Coming down to minus 3. X minus minus 3, that is x plus 3. Its power is 1, which is again odd. So I will cross the number line and done. And dear students, you can follow my previous YouTube video lectures to know about the details I explained about the how to approach towards solving a Wavy-Curve method. Now, what is our solution set? Our solution set, as it is greater than 0, we know that above the number line is always related to greater than 0 or greater than equal to 0. Our concentration is on greater than 0. So what are the solution set? The portion of the wavy curve which is actually, above the number line. So this is this portion and this portion. Correct, not dear students? So what we are going to get from here, we are going to get the solution from here. What you can say is that this implies x belongs to -3 to -2, -3 to -2, union, what we get is that 1 to infinity. Correct or not? But all will be open interval. Why? Because the inequality here is a greater than 0. So this is one solution we get. And another solution we get here in that top, here also one solution we get. Correct, no, dear students? Now we need to club this together. So if we club this together, these two solutions, what we are going to get? So this is, suppose we give equation in equation 1 solution set, and this is in equation 2 solution set. So if you bring this together, then by considering 1 and 2, what we get? That -3 less than -2 union 1 less than x less than 2. Correct or not? X belongs to, if you club this to 1, so it will start from -3 to -2, as it is there in that inequation set 2, -3 to -2 here, dear students. Then union, it is actually going from 1 to 2 because it cannot go beyond 2. Then it will violate the inequation 1. Correct, no? So union, it will go from 1 to 2, and that is the solution set. So this is the final solution set. Please feel comfortable. Any doubt, any smallest doubt, never hesitate to let me know. Correct, no, dear students? Okay. So fine, let me proceed to the next question, dear students. So we should solve few questions, couple of more questions I'm going to solve, so that you will get the different perspective, how to solve, how to approach these questions related to logarithmic inequalities. So the next question is you are going to get within a few seconds, and here it is, which I'm going to show you in the next page. So here the question is that find all x such that log of x base 1 by 2 is greater than log of x base 1 by 3. To solve this kind of question, dear students, you need to take a different approach. You need to make all this log, with the same base. So what I'm going to do, dear students, I'm just going to concentrate on log of x base 1 by 3. And what is my target? My target is that to transform that log of x base 1 by 3 with a log of x base 1 by 2. Log of something base 1 by 2 means I want to convert it to log of base 1 by 2. Then it will be helpful to approach this logarithmic inequality where left hand side we have log of x base 1 by 2. So let's see that how we can transform that log of x base 1 by 3 to log of with base 1 by 2. And here we need to use the properties of logarithm. So if you look into it, if you know that one property we learned is that log of a to the base b is equal to log a by log b. And when I say log a by log b, that means this log could be of any base in the right hand side. When I say that log a by log b, it could be of any base. So similarly, we can say it here is that it is log of x by log of 1 by 3. Now, as I can keep any base, so I give the base as 1 by 2, dear students. Correct, no? So what we are going to get is then, so from here what we are going to get is that it is log of 1 by 3. Okay, log of 1 by 3. So in the what, let me write one more steps. 1 by, we can say, log of 1 by 3 base 1 by 2 into log of x base 1 by 2. Now recall one property we learned is that log of a base b is equal to 1 by log of b base a, or the other way once you can say is that 1 by log of b base a is nothing but log of a base b. Correct, no? On the right hand side, what I'm doing is all the properties, usage of this property. So using this property, what you can see, dear students, is that log of x base 1 by 3 is equal to 1 by log 1 by 3 base 1 by 2 become log of 1 by 2 base 1 by 3. Correct or not? So that becomes log of 1 by 2 base 1 by 3 into log of x base 1 by 2. Correct or not? So now this value of log of x base 1 by 3 as represented as log of 1 by 2 base 1 by 3 into log of x base 1 by 2, we can apply here. So then what we are going to get? From this equation, we are going to get what? This inequation, by the way, we are going to get, this implies log of x base 1 by 2 is greater than log of 1 by 3, 1 by 2 base 1 by 3, this into log of x base 1 by 2. So now, from this inequation, what we can do, dear students, from here I can say, I can take log of x base 1 by 2 common. So log of x base 1 by 2, I can take common. Then what we are going to get? We are going to get something like this. 1 minus log of 1 by 2 base 1 by 3 is greater than 0. Now, if you look into it, that 1 minus log of 1 by 2 base 1 by 3 is always greater than 0. This quantity, if I use a different color, this quantity is always greater than 0. This quantity is always greater than 0. So as this is greater than 0, definitely log of x base 1 by 2 should be greater than 0. Okay, so how we can conclude? So from here we can conclude is that log of x base 1 by 2 is greater than 0. Now log of x base 1 by 2 greater than 0 says what? If you recall, dear students, here the base is in between 0 and 1. So definitely x should be in between 0 and 1. Follow the table, you will get it. This implies 0 less than x less than 1. So what is the solution set we are going to get? The solution set we are going to get x belongs to the open interval 0 to 1. And this is the solution to the given inequation that log of x base 1 by 2 greater than log of x base 1 by 3. Please have a look into it, dear students, and you will feel, comfortable about this thing. Any doubt? Never hesitate to, let me know. One more problem we will do, that will also be a little bit of different type. An extensive practice, dear students, as I always say, extensive practice, is required. And for that, the right place is online test platform at www.KonarClasses.com. That is the right platform for extensive practice. When you are, writing this thing, so I write this thing. log in there and go for the practice test and perform extensive practice. Your success actually directly proportional to the amount of practice you are doing. That is my analysis. Okay, dear students, now let me solve another problem. And after solving this problem, we will conclude the class for today. So here the inequality is something like this. Solve the inequality uh, that log of x base 4 whole square. And that is the way it is actually symbolically represented. So log of x base 4 whole square minus log of x base 2 minus 15 greater than 0. So what is the task here, dear students, is to convert everything with the same base. Okay. And obviously one thing, dear students, one solution to you got by looking into the problem, and that solution set is x should be greater than 0. Always, without for that you don't need to have any other knowledge of logarithmic inequalities. You need to have the fundamental, domain of definition of the logarithmic function, that x is greater than 0, so obviously one solution. Now, what we need to do here, dear students, is that we need to make this logarithm inequalities with same base. We can take let's assume that we want to convert everything to base 2. So from there, what we can do is that, so let me solve it. So there are two ways you can, one approach you can take is that, what is that? It is log of x base 4 whole square minus log of x base 2 minus 15 is greater than 0. Now, dear students, log of x base 4 is how we can convert with the base 2. That is going to become 1 by 4 into log of x base 2 whole square. If you use the property of logarithm, that is going to be 1 by 4 into log of x base 2 whole square minus log of x base 2 minus 15 is greater than 0. Some of you may have, sir, how log of x base 4 is become, 1 by 2 log of base 2. That then square become 1 by 4. Na? As I said, it comes from the property, but sometime you may forget that property. If you forgot that property, but your task is that you need to convert that log of x base 4 in terms of log of x base 2, you can do it. How? There is a way to do it. So you assume that log of x base 4 is equal to y, or some number, suppose p. So how you can, sorry, suppose log of x base 4, let me write properly, log of x base 4, you assume this is equal to p. And what is our target? Our target is to express the same p in terms of log of x base 2. How? Let's see. So from this fundamental definition, what we are going to get? That log of x by log of 4 is equal to p. And it could be of any base, no? As you know. So we can write, if we consider the base as 2, so here also it has to be base as 2. Correct or not? P. So from here, what we can say? P is equal to, in the numerator we get log of x base 2, and denominator is that log of base 2, but 4 means 2 square. So now if you use the power formula of logarithmic properties, numerator to as it is log of x base 2, so here you'll get 2 log 2 base 2. Power formula says that log of m power n is equal to n log m, dear students. And what is 2 log 2 base 2 is 1. So you get p is equal to 1 by 2 log of x base 2. And what was the p? P was log of x base 4. So log of x base 4 is equal to 1 by 2 log of x base 2. Now all these steps what I wrote in the green color, dear students, you no need to do if you remember the property of this logarithm. Exactly what this thing we have get it here now. After that what? So what the inequation we get? Whenever that you get this kind of inequation that where you find the log of x base 2 whole square as per any base, then log of x and this thing, then you better to assume log of x base 2 is equal to y. So let log of x base 2 is equal to y. Then what we are going to get, dear students? So we are going to get 1 by 4 into y square minus y minus 15 greater than 0, correct or not? And that is little bit of comfort position because we love to do, to solve inequations of quadratic, form, quadratic inequations rather than relatively complex logarithmic inequations. So from here, what we are going to get? We are going to get y square minus 4y minus 60 is greater than 0. And do the middle term factorization, dear students. You'll get y minus 10 into y plus 6 greater than 0. As we are discussing inequality, so let me write in the standard form which will help you to, make a conclusion. Y minus of minus 6. I'm sorry. Above step should not be equal to 0. Just a minute. It should be greater than 0. Yeah, greater than 0. Now remember, x minus alpha into x minus beta greater than 0. That means either x is greater than maximum of alpha and beta or x is less than minimum of alpha and beta. So here alpha and beta respectively 10 and minus 6. So this implies either y is less than minus 6 or y is greater than 10. Correct or not, dear students? Correct. So from here, y less than minus 6. What is y, by the way? Y was our assumption, log x base 2. This implies either log of x base 2 is less than minus 6 or log of x base 2 is greater than 10. So from here what we can say? We can say either x is less than 2 to the power minus 6 or x is greater than 2 to the power 10. Correct or not, dear students? So from here, what we can say is that obviously one statement is there, x is greater than 0. X is always greater than 0. Okay, this is an inherent one. So along with that, we should combine and x is greater than 0. Okay, which is obvious, correct? No? So if we combine all these things, either x is less than 2 to the power minus 6 or x is greater than 2 to the power 10 and x greater than 0. What we are going to get? It becomes x belongs to, it is actually 0 to 2 to the power minus 6. 2 to the power minus 6 is positive, but less number, very small number. Union 2 to the power 10 and it goes up to infinite. Correct, dear students? If you look into that, English statement, what I wrote one step above, that is either x less than 2 to the power minus 6 or x greater than 2 power 10 and x greater than 10. And the set theoretic notation I wrote in the next step, that is x belongs to open interval 0 to 2 to the power minus 6 union 2 to the power 10 up to infinite are same. Correct or not? Clear? So this is a solution set. So with this, I would like to conclude the class for today. I'll give you some assignments at the, I'll give some assignments. When I send the class notes, I'll send you some assignments and you can solve this thing. Meanwhile, as our time is up, we need to, conclude our class. So what you can do is that you can start solving, till you get the class note. It will take another 15 to 20 minutes to get the class note. You can start solving this, inequation. You can just take a screenshot of this particular, portion, or you can write it down, whatever. Please confirm that you write it down, or you took a screenshot so that I can conclude the class. And when I'll send you the class notes, dear students, I will send some more exercises. And with this, I would like to conclude the class for today. Could you please confirm that you wrote it down, this particular question? All of you?
Yes.
Sagnik, Devanshu, Disha, Srijita. All of you wrote it down, right? Okay, thank you very much. All right, bye.